Look at number 4. Number 4 says identify which transformations or sequences of transformations identified below will map ABC onto DEF. So the first thing you should do when you see a problem like this is don't panic. I would first write down all the points of A, B, C, and then DEF. So A, B, C onto DEF, that means A will be the same as D, so let's write A first and D. So let's write A is at -3, -3. And D is at 3, +3. Okay, let's do the first one, all this order, and then we'll confirm it, because we really don't have to be too harsh on all of it, because if it works for one, it's going to work for all most likely, and we could always double check with another point. Alright, so we're at -3 to 3. So reflect over the y-axis. So you would put your pen or something on the computer screen, and you would reflect over the y-axis. 1, 2, 3, 1, 2, 3. So when you reflect over the y-axis, we're at 3. So we're still going to be at -3, but we moved to -3. That's after the y-axis. We reflect it over. Then translate it up 3 units. If you translate it up 3 units, oh, did I just flip that? Yeah, it's 3, -3 still. Yeah, I did it right. So the y-axis reflection gave us 3, -3. And if we go up 3 units, you'd put your pen on 3, -3 on your computer screen on the graph, and you would go up 1, 2, 3. We would be at 3, 0. 3, 0 is not the same as 3, 3. Therefore, not done. We want to reflect over the y-axis, then translate down 3 units. Well, if we do the same thing and then just subtract, we go down 3, that's not going to work. You get 3, -6, which is not 3, 3. So the next one says we want to reflect over the x-axis, then reflect over the y-axis. So I'm going to rewrite this. A for our new one is at -3, -3. They first want us to reflect over the x-axis, which is the horizontal. So put your pen on A at -3, 3 and go over the x-axis. 1, 2, 3. 1, 2, 3. So now we're at, after the reflection of the x-axis, we are at, what is it? -3, +3. Then they want us to reflect over the y-axis. So let's put our point at -3, 3. 1, 2, 3. Stop. 1, 2, 3. So after the y-axis, excuse me, we're at 3, 3. 3, 3 and 3, 3 are the same. So good, we got it. We want to go clockwise about the origin and counterclockwise about the origin. This is kind of redundant because they're the same thing. You do 180, either way you're always going to end up in the same spot, just different how we started. So the rule for 180 degrees is that it's just going to flip the signs. That's it. So 180 degrees is always equal to x comma y, 2, negative x, negative y. So if I have like a negative 3, I get negative 3, negative 3, which I get 3, comma 3. So this could work. And if that worked, this one has to work for A and D. Let's not waste too much time and try it for B. Because it could work for one point. I'll do it right over here since it could work for one point but not another. So it looks like they all just changed their signs. So B is at negative 5, or positive 2. And B is the same as E. So E is at 5, negative 2. Is at 5, negative 2. Look at that, the signs just switch. Isn't that what happened with this? So that works. Okay. What about for C? C would go with F. C is at negative 1, 0. And F is at 1, 0. No signs for the 0, which wouldn't work for here. X-axis, or X-axis wouldn't move, then Y. Yeah, that works. To me, this works, and this works. Just a matter of just figuring out what works and seeing it works for the entire triangle, so we're good to go. They do map on top of each other through those three transformations.